All right, everybody, welcome to today's lecture. Today will be a relatively short lecture, and I just want to address a couple of additional topics that we just haven't talked about throughout the duration of the semester here. Nothing that we talk about today will necessarily show itself up on our final exam and final lab or anything. But it is important, I think, to at least talk about them, expose you guys to them, and then allow you to do further research and just generally be aware moving forward in your programming career. So one of the first things, and something that we really haven't talked about all semester, is secure coding. Secure coding is, here we go, get on this right page. Secure coding is definitely a topic of just primary concern and importance when it comes to writing software. At the 250 level, we're primarily concerned with writing code, learning how to write code, and understanding some of these core concepts. So, as you move forward in your career, especially here as you start taking more advanced courses at DSU, you will be exposed to more secure coding practices and standards. Definitely when you move into the private sector or the public sector, I guess wherever you start working, you start getting paid to code essentially, then that should become one of the primary concerns. And the organization that you work with should have a structure, a process in place to help you write secure code, to educate you on that if you're not, to learn the issues that whatever software you're writing for that particular company deals with, and also find bugs or find those issues when they crop up in the deployment process for your code. Again, big picture, that's far beyond the scope of this 250 course. However, I do want to point out a couple of good resources for that, and one of those will be securecoding.cert.org. And so if you take a look at this site, I'll zoom in on that a little bit here. Hopefully this comes through in the video. securecoding.cert.org. They have a Cert C coding standard, and it's probably the de facto standard for secure C programming. So if you take a look at this document, take a look at this page, you'll see there are a lot of topics here, a lot of information to go through. There's a book that is based off of this, or maybe the website's based off of the book, whichever. But all of these, there's a lot of concerns here. Again, probably haven't addressed the majority of these head on. We may have inadvertently or kind of indirectly talked about them. Obviously when we talk about arrays, accessing the index of an array that doesn't exist. If you declare an array of size 10 and you access index at 11 or 12, it doesn't exist. That's going to cause an error. And so you want to avoid that. But to take that one step further, you may need to check. You may need to provide some sort of validation to check this to ensure that doesn't happen. And a lot of those topics are covered in this site. So, I would encourage you at some point in time to go through and start picking through some of these topics, especially these core constructs that we've been working with, arrays and integers and expressions, declarations, and just start reading up on those. Let's see, a good example of one, if we look at integers, if we choose one of these topics, you're going to see there's kind of two sections to this. The first one being recommendations. Okay, so these are all recommendations, and again, choosing any single one of these, ensure, let's see, verify all valid integers are in range. Choosing that value, then it gives you information about it, and then also an example of non-compliant and compliant code. Okay, as well as some risk assessment stuff or metrics. So a very good resource because it assumes in a lot of ways here that you really don't know much about it, and so it gives you the background, and then it even gives you examples. If we look down at the rules then, okay, one of the first ones is ensure that unsigned integer operations do not wrap. So this would be integer overflow. And we can take a look at this. We can read about it here. Unsigned integer operations can wrap if the resulting value cannot be represented by the underlying representation of the integer. Okay, so if you have an unsigned value, okay, so that means it can be both positive or negative. If the value goes beyond the max value that can hold, it'll wrap, and it'll go from being positive essentially to being negative. You can take a look at some examples then. Okay, here we can see unsigned integer. The value of this variable usum is ui underscore a plus ui underscore b. And if those two values are greater than the maximum value that this unsigned integer can hold, then it'll overflow. How do you check that? You can write code like this. Okay. I do have an example of that, just so you can see what an integer overflow looks like. So if we take a look at this sample program here, we can include limits.h. That's a header file that has the limit, so the maximum value that any particular data type can hold. And here you can see that I'm going to print off simply two printfs. So I'm going to print off the maximum for an integer and the maximum or the minimum for an integer value, unsigned integer. I'm going to declare an int sum, and then I'm going to say that sum is equal to the max plus 1. Okay, so let's take that piece out. So we'll just say sum equals int max, and then we'll print off the sum. Okay, so there's the max, there's the min, and there's the sum. So sum right now is equal to the max. Okay, so everything makes sense. Now, if I add 1 to that number, as I previously had, what happened to the sum? It overflowed. It overflowed from the maximum to now the minimum value. Okay, so that integer overflow can cause errors in the program. It can be a bug. It can be a bug in the program simply because we didn't do any sort of range checking or inappropriately handled what we can store in an integer value. Okay, so there's a lot of examples here. There's another one which kind of go back and forth on throughout the semester, and that is typecasting the void pointer. We know that malloc returns a void pointer, and in this case, the recommendation by the Software Engineering Institute, by this coding standard guide, is to typecast it. And the main reason behind that, well, let's see, where did that go? Right here. It's just this line. This is the statement right here, this last sentence. Let's see here. We recommend casting the results of these functions into a pointer of the allocated type because it increases the chances that the compiler will catch and diagnose a mismatch between the intended type of the object and the actual odd type of the object. Okay, so what all they're really saying here is if you don't typecast it, the compiler will do it for you, but that can leave you open to errors, and that if you typecast it yourself explicitly, not an implicit conversion, explicitly, that this can help and catch bugs. You can catch when the void pointer returns a type that's not going to cast to the type that you want. And so if we look at some sample code here, okay, this is our classic example here of just simply allowing an implicit conversion. So there's our malloc, there's our size of this, whatever this struct, looks like a struct gadget, but we don't typecast it. And so if we scroll down a little bit here, we can see this is the recommended solution. Okay, so we just do a typecasting conversion, explicit conversion there. There's also a neat solution using a macro, and I'll probably talk about macros later this week when we do one more lecture here, and I introduce just a little bit some miscellaneous C topics such as macros, as well as an introduction to, more than likely, an introduction to C++. Right. So, anyways, here's a macro that you can check out, and you can see. Well, you know what? We'll take a look at this in the next lecture. All right, so take a look at it if you want, but we'll talk about this one when we talk about macros, because this is, I think, a very handy macro as well. So, anyways, that's the document there that I wanted to refer you to. So, again, we didn't talk much about secure coding in C, but it is a primary concern, and this is a good resource, a great place to start when it comes to writing secure. So you can see there's C, C++, Java, and Perl, and then it looks like, I think, a secure coding document just in general. OWASP, that also Open Web Application Security Project, also has a lot of great documentation, although you won't necessarily find a lot of documentation directly in C. Okay, so that's really all I'm going to say about that secure coding at this point. The last thing I want to introduce you to today is GDB. Okay, so GDB does not come native on a Mac, and it has its own version of it, but I'm not familiar with the commands at this point in time, so I found it just as easy to go into a VM here, VM much like you have, a version of Ubuntu, and look at some debugging. So GDB is gosh, I think it's the GNU debugger, and what it provides is the ability to actually debug the program. And so you'll see some arguments made by people that other people that teach C or that write C, is that you should start with GDB right away. And I can tell you that I'll probably change my classes a little bit. So in the future, this class will start with an introduction to GDB, and then move into actually talking about more programming concepts. I'm not sure yet. But anyways, GDB allows us to debug our programs. We can run our programs with the debugger attached and then actually inspect our program and sees things like the values of our variables. And so it becomes very handy when we're running a program and something's happening, a bug, a logic error, but we're not quite sure what it is. Using printfs, that's a very common way, at least at this point in time, and in other languages I've used to print off and in a way indirectly debug your program. But attaching a debugger is going to be probably the best, the most effective, and by a lot of people the most preferred. So what we'll have, we'll take a look at this program, really short, simple, Hello World-esque program right here. And let me get zoomed in a little bit. If I can remember how to do it. Nope, I don't remember how to do it. Okay, it's got to be in preferences here. There we go. Let's do 16. There we go. Alright, so that's a little bit better. So what you can see here is going to be a relatively simple program. I'm going to have one function. We'll take a look at that here in just a second. It's putting a print iteration, and all it's going to do is print the value of this integer variable that gets passed to it. A couple of local variables here, int I, num, and j, and I'm not actually going to use j in the program. We're just using num and I will be used for this for loop. It'll be a scanf and then a for loop, and all this program is going to do is say how many times do you want me to loop. So it'll prompt you, it'll store that value in the num variable, and then we'll use that in our condition for this for loop. All right, and then with each iteration, we're simply going to call that print iteration function and print off print iteration. Okay, so we can go ahead and let's go ahead and compile that. Oh, goodness. Save it, compile it, just to make sure I didn't introduce any errors. Okay, clear, and let's run it. All right, how many iterations do I want? 4 iterations, 0, 1, 2, 3, 4. Okay, so obviously there's an error here, and what I'm going to do, again, this is very trivial. This is just an introduction to GDB, but I'm going to use it to try to debug the program here. Now, obviously, with something this simple, if we're getting more iterations than the number we want, I said how many loops do I want? I want 4. How many iterations do I want? 4. We end up printing off 5. We would look at the loop and see that the error is obviously right here in my condition. Either the condition is off, where I'm starting is off, how I'm incrementing is a little bit off. You know, between these two, and most likely the condition is all I would need to change here. So how do we run this with GDB? Well, the first thing we have to do is we have to compile it with the -g flag. Okay, so it's gcc-g and then the name of our C file. So in this case, debug.c. That generates an a.out file, but it attaches the debugging information that allows GDB to work. If you forget to compile the program using this flag, then GDB will not work, and it'll tell you that it can't find the information and it can't attach it, so it's just not going to work. Once we have that version compiled, then all we do is GDB and then the program name. Okay, and then you get this information here, kind of copyright software information and reading symbols, and it looks like we're all good to go. Okay, so this is more or less what you should see when you know that you're now running your program in GDB. The first thing you have to do is you need to set a breakpoint. If you don't set a breakpoint, then this is just going to simply step through and run your program in its entirety. So we want to set a breakpoint. And if we look at the program here, I'm simply going to set a breakpoint at, I'm not sure why these line numbers are cut off, but we're going to set a breakpoint at line 14. Okay, so what we can do is we can say break at 14. Right? And then you should see breakpoint 1 at this address in file debug.c at line 14. All right, so that confirms that we've set the breakpoint. We need to set a breakpoint before we run the program, otherwise it's not going to stop. It's just going to run the program through without stopping anywhere and allowing you to expect what's going on in the application. So we have a breakpoint set. Now we can type in the keyword run, and it'll start the program. Okay, at this point in time, we haven't hit the breakpoint yet. We set the breakpoint at 14, and we hit this first scanf. Okay, so it's just running the program as if you ran it from the command line. So how many loops do we want? Let's just do 1 loop. And now you can see we've hit a breakpoint. Breakpoint 1, and we're at this point in the program. So we're inside the loop. So what we can do now is we have some commands. Let's say that we want to print. Obviously, one of the main things that we're going to want to do here is probably print off the values of our variables. So in this case, we can do print and then whatever the variable name is. So print I, the value of I equals 0. Let's take just an aside here and take a look at the variable j. Okay, j is a variable, but we didn't initialize it to any value. So what does j have for a value? Optimized out. Okay, so that didn't go as I expected, and I'm not actually sure what that means. So I'll have to come back to that. Sorry about that. All right, so print I, we know that'll work. We can print num, we know that'll work. I is equal to 0, num is equal to 1. We wanted one iteration of this loop. Now, once we've hit a breakpoint and we're done inspecting, we're done printing the values off, we have a couple of options. And here's a little cheat sheet that I've developed for us to look at. Here's the printing, so print in the variable name, or there's a shortcut. You can just do P and the variable name. But now we have three options for continuing: C or continue, N or next, S or step. So if you hit C, C just continues and it runs the program and never hits the breakpoint again. So if we go back in here, we hit C. There we go, continuing. I'm sorry, it continues until it hits the breakpoint again. So at this point in time, we've hit the breakpoint. We can hit C, and there we go. Iteration 0, iteration 1. That's a problem. We only wanted one loop. We got 2, but now it's done. Okay, we still have the breakpoint set, so we can run again. Just do one iteration. And that's what continue. So continue is going to run the program until it encounters its next breakpoint. In this case, we're just going to encounter the same breakpoint again until we break out of that loop. The next one is next. Okay, so next will allow us to step line by line. Okay, so we go back to this point in time. We've hit the breakpoint for the first time. We can print I. We can see it's at 0. So if we type in N or next, either one, that'll give us the next step. Okay, so if we go back and look at the program, we went from print iteration to the for loop. Okay, and we can see that right here. We can print the value of I should still be 0, because we're now at this statement. We haven't done anything with it yet. So we hit N, go to the next, we're now inside the loop, we print I, we can see that I is now equal to 1. Okay, so next just takes us line by line. Okay, back to the loop, back to, no, we're done with the loop, condition is now false, and now we've hit the return. One more time, last curly bracket, and it looks like we're probably done. Okay, so one thing you may have noticed is that when we're stepping, we hit this function, but we didn't step into it. We just kept going next, iteration, back to the loop, back to the print, back to the loop, back to the print, until we broke, the condition broke, and we moved on. And so the last command is step. Okay, it's just like next, except that it will step into the function. It won't treat it as a single instruction. So in this case, if we run this program, let's just do this again. GDB.out, break at 14. Right, yep, break at 14. Run. Just want one loop. Okay, so now we're at this print iteration instruction. So instead of doing next or continue, if we do step, we've stepped into the function. All right, so now we'll go line by line inside of that function. So you can see here, we're at this step, print iteration, iteration. Okay, so of course, if we wanted to print, we can. Value is 0, which was what we would expect. We hit next. At the end, we just printed off, so we got the output generated from that function call, and now we're back into our main program. Main at debug. Okay. All right, so now I hit continue, and in this case, I'm just going to do a couple of next. Okay, return 0. So we've broken from the loop. And so this is the whole purpose of this. Again, very trivial, high-level example is what's wrong, or what is the value of my counter? That's probably the one thing I'm going to focus on here, because I'm getting more iterations than I want. I said I wanted 1, and I got 2. So what's the value of I once we're done with the loop? It's at 2, which is 2 too many. Right? So we know then just by printing off that value, helping us inspect the value of these variables as the program is executing, what those values are. Okay. So, again, very short introduction to GDB. I will upload this sample code into our class site so that you can take a look at it. and run it. I would encourage you to do that, or take any program really that we've written over the course of the semester and run it through GDB, step through some of the execution, print some of the values of the variables, and overall allow it to help you. Now, GDB is command line driven, right? So if you haven't used, or if you are using, I guess, Visual Studio or Eclipse, there are some IDEs out there that'll allow you to write your code, your C or your C++, set the breakpoints and run through it through that tool, through Visual Studio, and it becomes a lot easier to do your debugging. But because this is something that we have available on all of our machines, it is there, and it gives you the same idea. You run the code, you set breakpoints, you inspect the values of the variables, you can trace through the execution, right? Let's say that this program was much more complex, and I had a lot of if-else and conditionals and branching logic. Then I could step through the execution to see that the path that my program takes, depending on the different inputs or however it's being ran. And so it can help you to debug your program, again, a lot more efficient, a little bit quicker than necessarily just doing a bunch of printfs or just guessing and staring at your code endlessly trying to figure out where your problem is. So if you have any questions on GDB, again, please feel free to contact me, let me know. Again, very short introduction just to give you the idea, basic concept behind it. Later on this week, we'll talk about C++ and a couple of other concepts in C that I want you to at least be exposed to, but again, nothing that's going to be critical to finish off the semester. So hope everybody enjoyed, and I'll talk to you later this week.